If you dive deep enough into the ocean, the rules of biology start to feel a lot more like science fiction. In this alien environment, marine life evolves into massive, surreal proportions simply to survive. For most of us, the baseline for an ocean giant is the blue whale. It is the largest known animal on Earth, routinely growing up to 100 feet long, which is longer than a professional basketball court. But there is one historical anomaly. In the icy waters off the coast of Antarctica, whalers documented a single blue whale that measured exactly 108 feet long. This chart shows the relationship between a whale's body size and its muscle fatigue. According to Dr. Gene Putman, 108 feet is the absolute biological ceiling. Notice the steep spike right at that threshold. If a biological body grows any larger, it faces perilous recovery times after diving because it cannot clear the lactic acid fast enough. So we have a hard boundary. If 108 feet is the absolute physical limit for a single body, how do the darkest parts of the ocean hide creatures that drastically exceed that boundary? The first way to bypass that size limit is to change how you experience time. Descending thousands of feet into the freezing, pitch-black abyss forces the metabolism of marine life to an absolute crawl. Take the Greenland shark. It is a massive 21-foot predator that navigates the freezing waters of the North Atlantic at depths of up to 3,000 feet. These sharks do not reach their immense size through fast growth. They achieve it through extreme longevity. Scientists estimate their lifespans stretch anywhere from 250 to 500 years. That means there are likely sharks swimming in the Arctic today that were already alive before the United States became a country. We see this same slow growth hack in other species. The colossal coral, known scientifically as Pavona clavis, has reached the size of 2 basketball courts by quietly growing polyp by polyp over centuries. In the freezing depths, gigantism is not fueled by rapid consumption. It is achieved by extreme patience and outliving every other threat in the water. Specific target, the elusive giant squid. These are fierce physical battles. We have actual footage of sperm whales surfacing after a dive, with giant squid tentacles still wrapped tightly around their jaws. The giant Pacific octopus is another heavyweight in this cold water arena. The largest recorded specimen used a 600-pound frame and arms stretching 30 feet across to dominate its environment. That sheer physical power is paired with extreme intelligence. They are capable of solving puzzles, twisting open jars, and escaping heavily secured enclosures. In a resource-starved ocean, growing to monstrous proportions is a brute force evolutionary necessity to ensure you are the predator, rather than the prey. So, time and brute force get animals to incredible sizes. But how does nature build a body larger than the 108-foot physical limit of the blue whale? The answer was discovered off the coast of Australia. This is the siphonophore. It is an impossibly long, spiraling predator drifting through the pitch-black water, estimated to be more than 390 feet long. The biological cheat is this is not a single animal, but a massive colony of specialized clones linked in a chain. They divide the labor, some dedicated to paralyzing prey, others to reproduction, and some to moving the colony. True rule-breaking gigantism is achieved when life stops fighting as individuals and starts functioning as a single coordinated titan. Deep-sea gigantism is a calculated response to a hostile environment. By utilizing deep time, evolutionary brute force, or colony biology, marine life has successfully bypassed strict physical limits. And we are still finding completely new examples, like the giant phantom jelly. It operates like a living shadow, with 30-foot ribbon-like arms gliding silently through the abyss. It is an elusive creature that has only been observed a handful of times in the last century. Scientists still do not fully understand how its stimulus arms actually capture prey. This chart visualizes a staggering reality. Marine scientists estimate we have only surveyed about 5% of Earth's underwater world. If evolution has engineered these massive titans in the 5% of the ocean we actually know, what unfathomable giants are still waiting in the dark?